So good morning. So today, we're going to be talking about the use of R for regression analysis. Just like a very short introduction. So what is R? So it's a metrics-based programming language and also like an environment for statistical analysis and graphics. It is, widely used by statisticians, but it is gaining popularity in other fields including economics, and probably one of the reasons because that's happening is because R is free in contrast to some other commercial softwares that they're available. So there is a lot of activity with R. A lot of people, a lot of scientists, and even the industry working with R. So there are a lot of resources available for for its use. Now, specifically, since we're trying to learn to use R for regression analysis, we need two things. So the first one is going to be the latest version of R, and in this version, that includes some basic regression commands, and this can be downloaded from this website www.rlineproject.org, and then we'll also be using something that's called RStudio, which is an environment that makes it easier to use R. Once RStudio is installed, actually we don't need to open R in the background. So when you have, like in your screen RStudio in the background, R is the one that is running the programs, but both programs will be automatically connected and needs to be downloaded from rstudio.org, and that's kind of what I'm going to be showing you right now. Okay, so let's start trying to get the program. So I'll go to the browser and then I'll type www.rlineproject.org, and I'll show you how you can download the R program. So let me see, go to my browser. I'm going to be using Firefox. Well, let me type www.r, so that's a line, project.org. Again, you see it's www.r-project.org. And then, so, we get to this R project for statistical computing. And then basically what we want to do is we want to download. So we can click here to download R. So, there are different places where you can get R. I usually tend to use one that's closer to where I'm located, which is in the United States. And there is a place in Dallas. This is the closest to the place where I'm located. So again, you go to the US, all these different options, and then I'll click this. It's available by this institution, Revolution Analytics in Dallas, Texas. I will click it there, and then I go and click and download R for Windows. And then, since this is the first time that I'm installing R in this computer, I will click install R for the first time, and then download R 3.6.1 for Windows. I'll click up again in this link and save file. Okay, so here you'll see what's the progress of the download of the file. When it's ready, it turns blue. One of the advantages of R is it's not like a very large program, so actually it's pretty fast. I click here, and then I'll just follow the I'll follow what the program asks me to do. So do you want to allow this app to make changes to your device? Yes. The language, you can set up here different languages. I just use the default options given by the program. Says okay. So this is the the license. I click yes. Again, the default location where the program is going to be located in my computer is under program files, under R 3.6.1. Click next. I keep clicking next, use the default options given by the program. Just keep clicking next. I mean, if you want to add a shortcut, as I was telling you, since we're going to be using RStudio, that's not necessary. So I just keep clicking next, and now the files are being extracted and are going to be placed in that file in my computer. So again, I mean, this is relatively fast, so it won't take more than a few minutes, but we have to wait while all these files are being saved in the computer. So once we are done with that, then we'll start also downloading RStudio. Okay, so click finish. Again, as I was telling you, what we're going to be using is also RStudio, which is this environment to work with R, and that really makes our life easier. So let's again go to the browser and let's type rstudio.org. Click enter, and we want to download RStudio. Just click here at the top, and then there are different options. Some that are free. The one that we need is RStudio for desktop, so that's free. Just click download. It gives you the installers for supported platforms. I have a computer with Windows, and I guess this is for any Windows 7 and up. So that's where I click. Once again, save file, and again, it's pretty fast. So just click there in the open file, and the program will start to be automatic. Will start to be download automatically. So again, I mean, I'll say yes to everything. Click next. Finds a place where the program is going to be saved in the computer. Click next, and just click install, and then the files are started to be extracted, and then they will be saved in my desktop. Again, it will take a couple of minutes, but this is relatively fast, which is great because there are some of these commercial softwares that it takes sometimes hours to download and install in the computer. Just click finish, and we're ready now to start working on it. So I'll look for the program RStudio and open the app. Okay, so and this is RStudio once again. So this is the environment to work with R. The program R is working in the background. If you want, you can go and open R, but as I was telling you, that's not necessary. We can work here with RStudio. So at the beginning, you will see these 3 windows. So some basics about R, and that's what I was telling you before. So this let me close since I'm not going to be using that. So basic R concepts. So this is the R prompt, that design for more than. So that's the prompt. So if you want, you can add comments in the functions directly here in the console. So let's say, for example, we want to create a variable that we call it C and make it equal to 1. So you can type that, click enter, and you see to the right here that value has been created. So you can create the specific values, you can create matrices, etc. Let's say create this other variable, which value is 2, click enter, you'll see that this value has been created. And let's do an operation where we're going to have C plus A, click enter, and then if you want to see the value, you just type D after the prompt, and that will give you the value. And so remember, we were saying that R is a matrix programming language, so that basically this is a matrix with 1 row, and the element is 3. Okay. So again, some basics. So we could do that. I was using the equal to assign values. alternatively, you can use the less than and equal to assign specific values. That's another option. So you have several functions within R. If you have a specific question about a function, what you do is you type is like this interrogation mark in the name of the function. So for example, the function for regression analysis, which is linear models LM, is LM. So if you want to know some more about that, you can go here to the main console and type interrogation mark and LM, click enter, and you will see here that gives you, all the information that, a lot of information about this specific function. So that's basically a way to get help for specific functions. Now, in this R studio environment, as you can see here, and I didn't talk much about this specific part of the this window that is at the bottom in the right corner. So here, we can see all the different files that you have been using. You will be looking at plots here. So packages, later on I'll explain a little bit more about packages. But so you have the basic SAS environment, but some people, the contributors to R, add these different packages that you can use for specific purposes. When we download R, basically we have the basic R package and some other packages, and later on, actually, again, I'll tell you how we will continue. We'll have to download some packages for the analysis, but now we have the basic packages that we'll be using for our analysis. I told you help, and we don't need to worry about these other parts for now. So at the top, we have the environment, so which is the variables that we have in the environment where we're working currently, the history of all the commands that we have typed, and for now, we don't need to worry about connections. Okay, so just that you get a little bit familiar with what you are looking here in front of you. So, and this ls command, if you want to see all the data of the variables that you have created in the environment, you can type that ls in parentheses, ls, open parentheses, close parentheses, click enter, and we created these three values a, c, d. If you want to delete some of these variables, you can use rm. So for example, I want to delete the variable a, so you click rm and a, and with that you can see here that we're only left with cd. Now instead of typing that, what you could do is you can go here, you see this broom here, so that clear objects from the workspace, ask the question, and all those objects that we had created have been now the environment is empty. They have been deleted. Okay, so that's kind of the basics about like the structure of R. Now, of course, so you can type all the commands and do all the operations here in the main console. But usually, especially if you're doing research or you have a project, it's better to create what's called an R script. So to do that, you can go here to File, New File, type R script, and then you can start here, typing all the programs and all the commands, etc., that you're going to be using for a specific project. Just to practice, let's type a couple of commands and you will see how it works. So now, when you are creating these scripts, you want to differentiate what's text that you use to, so you can write text explaining your code, and so and of course you're gonna have also the code itself. So let's say this is just example for creating an script. Okay, so that's not part of the commands. This is just the text with information about a specific script, a good idea to save it. So I'm gonna be saving it in in any place where you want it saved. So this is, I'm gonna be saving in this file, and I'm gonna be calling it example script with a name. So now it's saved. And here you can start typing uh, your 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 comments. Okay. Now to make our life easier and to be able to move a little bit faster, I already created a script. So that, when you're doing research, I mean, you have a real life project. What you can do is you can go and open that script. So I'll go and open that file. So it's open. So you see, this is what I call lab one, and this is the script that I already had created. Um, again with instructions about what I have inside. And so here you can see all this text that is in green and that has the number before the text. That's not actually, that's not part of the code. Those are not comments. Those are just comments. So this is introduction to regression analysis. And so here I've divided this script in three parts. So the first part, we'll learn how to import data from an Excel file. Now it's possible that you actually enter the data directly here in R, but nowadays, I mean, if you have a real world project, it's very likely that you have all your data like in an Excel file. So the first thing that we'll be learning is to import this data from Excel. Again, so the great thing about RStudio is make our life very easy. So to import a data set, we go to this, to the window that's to the right at the top, and you see there is this command here that says import data set, and we're going to be importing it from Excel. So in some cases, I think that the first time that you are importing RStudio, it's very likely that you will get there a question asking you if you want to download this package to import data. So you have to say yes, and that this package will be automatically saved. For some reason this time, in the past where I was practicing for this lecture, the program was asking me several times, but it seems that this time it automatically downloaded. So anyway, so once you have this environment, you just have to go browse and look for the Excel file. And if you don't have the Excel file, you will see that actually it's a very short file. So actually, you can create it yourself. It won't take more than 2 or 3 minutes to create it. And then, so you look for the file, click open. So this is the data preview. So we have 3 variables: a variable that I call expenditures, another variable that I call revenues, another variable that I call type, and we only have 5 observations. So make sure that here you have first row as the names of the variables, and open data viewer means that you're gonna be able to see, I mean, what is that you are importing, and then you just click import. And you can see here in global environment, that means that the file has been imported, and actually you can look at the data here. Okay, so it doesn't need to be open, but it's good that you have it there. So again, so we can go back to our script. So that's what we have, and these are the instructions. And something to notice is that the name of the file is example SLR, and here I have an explanation of the variables that we have. So add expenditures, I mean, it's an explanatory variable, I call it X, and these are expenditures in advertising, and the units are hundreds of dollars. So it's $100, 200, 300, 400, 500. Revenue, I call it Y. Sales revenue, this is in thousands of dollars. Again, so that means that it's 1,000, 1,000, 2,000, 2,000, 4,000. So these two are numerical variables, and I also have this variable that's non-numerical variable, because I mean it has text on it. And I call it type. So and I have TV and radio. Okay, so kind of these describes the type of advertising that, that we have. Okay, again, so what you could do if you don't have the file, I mean, you can create it first in Excel, save it as an Excel file, save it in a place where you know within your computer, and then you can practice importing this data to the our environment. Okay, so now we have the data. Again, here, so we have more comments. We'll be estimating first some basic summary statistics, first some summary statistics for numerical variables, and the command that it uses this command that's called summary, and then you have this parentheses, and inside you have to place the name of your file. Okay, so this is a command that 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 we can use. Now, how do we run these commands? So right now, if you see this small script, I have a lot of commands, and all these commands correspond to, you see all this text that is in black. Actually, I don't have that many commands. So if I click here, run, all these commands will be run simultaneously. Well, not simultaneously, actually we'll go one by one, but it will run all the commands. But if we just want to run one of these commands at a time, what you need to do is you need to highlight the text, as I've done it here, and then you just click run, and then here at the bottom, you will see the output of the analysis. So again, we have three variables: operating expenditures. Here in summary statistics, it will give us the minimum value, the first quartile, the median, the mean, the third quartile, and the maximum. So the same thing for revenues, which is a numerical variable, and for the last one, of course, it's not a numerical variable, so it doesn't give us a minimum value or a maximum or the mean. Okay. So another way in which we can ask for summary statistics is by describing the specific variable. So let's say that we only want the summary statistics for the variable ad expenditures. So to do that, the way to do that is we type summary example SLR. So that's the $sign. And then here, actually we can specify the variable. So we want only the summary statistics for ad expenditures. So one way to read about this command is we want summary statistics for the variable ad expenditures, which is in this file, in the example SLR file. So again, highlight, run it, and then you see that we're only giving summary statistics of the minimum, first quartile, median, mean, third quartile, and maximum for the variable ad expenditures. Now, some summary statistics for non-numerical variables. We can use this command table, and inside we have to specify the variable. So again, this is for non-numerical variables. In our case, we have the type variable, so we can use this command table, and again, inside we specify the file, $sign, and the name of the variable. We highlight it, we can run, and that tells us that we have, for radio, we have 2 observations, and for TV, we have 3 observations. And again, we're talking about summary statistics, basic information about the variables. We can also draw a histogram. So the command for histogram is hist, and once again, inside we specify the file and the specific name of the variables. We will do a histogram for revenues. Highlight, run, and this is, here on the right at the bottom, you will see the histogram. So we have 4 observations that are between 1 and 2, and we have 1 observation that's between 3 and 5. So plots, we can also do plots, 2-dimensional plots, 3-dimensional plots. So let's start with a 2-dimensional plots. For our regression analysis here, so we're interested in looking how that ad expenditures affect revenues. So we want a graph in 2 dimensions where we have revenues on this vertical axis, the y-axis, and ad expenditures in the horizontal axis, so that's x-axis. So that's what we can do here. So the plot, So here, the explanation, basically x will be, this will be the horizontal axis, and the second variable should be place in second. And again here, the way to specify the name of the variable in the specific file, we first add the name of the file, write dollar, and that's the name of the variable. So we highlight that part, click run, and this is a 2D graph. So as you can see here, so these are the data points, and more or less you can see that's kind of like a positive association at this point between ad expenditures and revenues. So the higher the ad expenditures, the higher the revenues. We can also calculate confidence intervals for our variables. So we can use this command that's called t-test, and then we specify the name of the variable within a specific file, and here we specify, so if we want like a 95% confidence interval, we just write 0.95, highlight that. So here we have a t-value, the degrees of freedom, the p-value. So of course, so this runs a test for the null hypothesis that the revenue is equal to 0 versus the alternative that is not equal to 0. We're not interested in that test at this point. What we're interested in calculating just the confidence interval. So the lower bound for that 95% confidence interval is 0.47, and the upper bound is 3.52. If we want to calculate a 95% confidence interval, we're just going to change the number there, 0.90, highlight again that area, click run, and then again we see that the 95% confidence interval, the lower bound is 0.83 and the upper bound is 3.17. Okay, so that section, just to obtain some basic summary statistics, here the focus is on regression analysis, but every time that you do regression analysis, it's a good idea to get a feel for the type of data that you have. So it's good to calculate the summary statistics, and sometimes even to graph some of the relationships, especially if we're talking about the simple linear regression model. So for the simple linear regression model, the command is lm then so y is the name of your dependent variable. We have this tilde here, the sign tilde, and then x, which is the sign of your explanatory variable. So in our case, we want the regression of revenues as the dependent variable and ad expenditures as the explanatory variable. Highlight, run, and here at the bottom you see we get the coefficients. The intercept is minus 0.1, and the slope of the relation of the estimated relationship is 0.7. Now we want to see the complete output, so that we not only estimate the coefficients of our simple linear regression model, and I guess here I'm going to write here the model that we're trying to estimate. So this is B0 plus B1x. Okay, so I'll add that. Well, and since the regression, we need also like the error. So remember, what we're trying to estimate is beta naught and beta 1. So the intercept, this is our beta naught hat, what we estimated, and the 0.7 is our beta 1 hat. Okay, so those are the estimated values. Okay, so if we want to see the complete output with standard errors, tests of hypothesis about each of the coefficients, what we need to do, we have to use the same command, the lm, where we specify the y and the x, but we need to create like a file, and you can give it any name. Here I decided to call it lm.slr, so that's the name of a file where I'm gonna be saving all the output from lm, and then I'll ask for the summary for all the information that has been saved here in lm.slr, and again here you can use any name. So I'll do that and just run, and then as you can see here we get the complete output for our regression analysis. So it has some information about the residuals. We only have 5 observations, so it gives us all the residuals for the 5 observations, the coefficients, the intercept, the standard error. So this is beta naught, beta 1, standard error, the t-values, the p-values. Um, it tells us, which are significant. So here, for example, only this one is significant, and give us the significant code. The standard error of the residual, um, the R square, adjusted R square, and some F statistic. Okay, so basically that's kind of the simplest way in which you can obtain um, regression analysis estimates using R. Okay, so what I was telling you, so here what we're doing, we were highlighting each of the commands. What I'm gonna do right now is I'm gonna let me go. I will clear the console. So I deleted everything that I have, and what I'll do here, I'll run everything. Oh, let me see, what did I do here? Let me see if I run. Well, it's only running that one. What? I thought that everything will be run, but for that, I guess, let me see if I highlight everything. And yeah, you actually have to highlight everything, and then everything that we have in the program will be run. Oh, and all the graphs will also be generated, and we have several plots. So this is the histograms that we had before. We have them again here. Okay, so and basically, that's the introduction. Well, I guess, we saw how we can download the R Studio. Kind of a general understanding of what's the structure of R Studio to do basic regression analysis, how to import files, and we also learned about these scripts and how to run these specific commands that are needed for regression analysis. And I guess the last thing is that, before I finish, and I almost forgot, so remember always to save, your file. If it was, remember, it was in red. You see, if I do a new change here, I just wrote GGG. If you want to save that, you have to click, click here the save command. Of course, I don't want that, but remember to save because before you finish, and then we can close everything. We can close R, and we'll be ready next time that we open our file and redo all of our analysis. Okay, so I don't want to save the workspace, so I can close everything. Okay, well, thank you.